Water is one of the essential elements of life, and access to clean and safe water should be a fundamental right. But imagine living in a world where it's a luxury. A world where only a select few can afford. Unfortunately, this is not a distant reality but a global problem affecting billions worldwide. According to the World Health Organization, WHO, over 2 billion people lack access to safe drinking water. This is particularly prevalent in developing countries, where inadequate infrastructure and resources make it difficult to provide clean water to large portions of the population. Living in the United States or abroad, the risk of contaminated water constantly threatens health and well-being since contamination can lead to serious health problems, including diarrheal diseases, typhoid fever, and cholera, among others. The first step in addressing this crisis is to test the potability of water sources, but testing for basic parameters can take up to 48 hours, and even then, testing for contaminants can take up to 3 weeks. Meanwhile, the demand for water for basic human needs continues. Having no remedy to this problem will need people to wait for weeks to know if the water they are drinking is safe while continuing to use it for cooking, cleaning, and even bathing. The consequences of not addressing this problem go beyond just the physical health risks. The mental well-being of people can also be affected, as they may feel a constant sense of worry and anxiety about the safety of their water source. The stress of not knowing if the water they use for everyday activities is contaminated can take a significant toll not only on people but for the communities. That's why a solution that reduces the turnaround time and cost for water testing is so critical. With faster decision-making in managing scarce water resources, we can help prevent the consumption of contaminated water, reduce the impact on human life, and prevent economic losses.
With Trinity, we offer a cloud-based AI-driven solution that takes advantage of carefully trained models and a custom-built IoT sensory array module that can revolutionize water quality. Simply put, our solution gathers information on water quality parameters and feeds it to AI models that assess the water quality index and ascertain its potability. The data is then stored on our platform, which users can access quickly through the mobile application. All of this will be made possible by creating a unique sensor array that can be 3D printed and plugged into your smartphone's USB-C port. The sensory array will be able to gather information on various aspects of water quality, including pH, turbidity, and dissolved oxygen levels. A 500x microscopic camera will also be integrated into this sensor array. Trinity's equipment will be able to both identify contaminated objects and quantitatively determine the characteristics of the water sources. The Trinity smartphone app will feed the deep learning models with the collected numeric and image data points. The Trinity app will allow users to monitor the quality of their water sources without relying on costly and time-consuming laboratory tests. A user can register and then log in with their email address. Once authenticated, they can learn more about Trinity, perform a test on a water source, or view past tests. When running a test, the app will recognize the plugged-in hardware, calibrate it, and prepare it for testing before presenting the results and classifying the potability of the water source. If the user wants to see the results of previous tests, they can do so by going to the appropriate screen. Trinity will also include a community outreach feature in which multiple users can share their results in a geographic network, highlighting the presence of safe water sources in a specific area. As we continue to develop our proposed solution, we see a bright future ahead. Our modular microservices approach allows for adding more sophisticated features that can cater to a more extensive consumer base, allowing Trinity to improve the performance of our models continuously, catalog the water quality across geographical areas and even detect patterns unseen before, predict changes in water quality in the near future, formulate strategies to treat water from intake sources by leveraging past data points, diagnose sources of water contamination in real time. With time, we aim to make our solution an all-encompassing platform for water quality monitoring, management, and treatment. Finally, we'd like to thank your support in advance to help realize this goal.